Hello again from my workshop. Today I'm going to be talking about an aspect of the hobby of model engineering, or in fact the practice of engineering in the full size. Sometimes, and surprisingly often, the tool that you need or you want to do a particular job doesn't exist, or you don't have it and you need it faster than it's going to be able to turn up from China, which is where everything seems to come from these days. So tools are necessary and are driven by the techniques that we're using, and techniques become necessary to solve various problems. So today the first thing I'm going to do is to look at making a device called a trammel. This is basically a stick with 2 points, very crudely, and the reason I'm going to need it is it's going to be an essential measuring and marking tool for working on the valve gear. The first problem I have, or not problem, the first thing I'm dealing with here is to get the exact spacing between the axles on this model. There's a number on the drawing, and normal practice is, if you're building from scratch, would be to start with a trammel and mark everything starting from the frames with that trammel set to a particular point. Quite often people make a very specific thing, a single use trammel, just to do this job and carry on through, because you're going to use it to mark the centers of the axles on the frames. You're going to use it to mark the conrods, and that's just the basics. And then you have the same challenge of getting exactly the same distance between 2 points across a lot of the other rods, connecting rods and valve gear parts of one sort or another. I don't have a trammel. Well, I don't now. Hopefully by the end of this video I will have a trammel, and hopefully you'll see how I came about to make it. Thanks. So this is the setup. It's going to be 13.5 inches long. I've got a piece of 1/2 inch by 1/8 inch to make the beam, and the two spikes are going to be something like this, and I'm going to use a bit of 1/4 stainless steel bar that I have to hand. So the first thing to do is to start making the pointy bits, and I'll go over to the lathe and we can look at that. So this is a very old lathe speed calculator. It was published some long time ago, 1950 something, in Model Engineer. What I've done is I've marked up the 6 speeds I've got on my lathe. The idea with this is you just use a straight edge to go between the material size and the material type. Now, it doesn't do stainless, but it does nickel chrome, which is as close. So if I go from there to there, I'm almost dead on 640, which is what the maximum speed for the lathe is. So I might as well start there and see how that goes. So this is the setup for cutting the points. I'm using an ER32 collet. It's not a collet chuck, it's a collet on a mortise taper 2, which goes straight into the shank of the lathe. I just cheaped out here. One of these days I will buy a proper collet chuck for this, but in the meantime this works really well. Keeps the center. These aren't that expensive, especially from China, but they certainly do the job. I've set up the cross slide and this so I can cut at an angle at 15 degrees, which will give me a 30-degree point, which is what I'm looking for. The carbide I'm using is actually meant for aluminium. They're very sharp compared to the majority of carbide points, and I find that they do give a much better finish. So not ideal. However, I'm going to give it a go and we'll see how we get on with this. that looks pretty good. Just like that. That's not bad at all. I'm just going to put some emery on that just to make it really nice. And finish it with Scotch-Brite. Okay, what I'm going to do is reverse the piece of material I've got and do exact the same on the other end. Okay, so I'm going to face this down to the finished length. I've basically marked it up and scribed it, set the DRO on Y to 0 and just face this until I get to where I want to get to. Okay, on the mark. Okay. It doesn't matter because we're going to, oh, it does matter. We need to get that finish a bit better. Emery paper, where have you gone, emery paper? There we go. So a bit of emery, and then we'll just chamfer the end a bit because we want to get a nice lead in for the dye. Okay, so that should be ready to thread. So it's a bit of an episode about homemade tools, and here's one I made earlier. This is a very simple tapping arrangement that goes in the chuck. So we've got 2BA tap in there and offer that up to our workpiece. Now what I've done is I've set the jaws in the tap open at the moment so that I can get a start on this, or try and get a start on this. I mean, cutting stainless is never fun. Trying to get a carbon steel tap to cut stainless is definitely going to be a challenge. So I will revert to my favourite metalworking fluid to help this along a bit. Oops. Let's see how we go with this. You're not seeing a lot because I keep bashing into the camera. It's cutting all right. Just going up to the mark we've got on the blue there. Should do us. Move it back. Pull that back. That looks like quite a good thread. Let's just get a 2BA nut and see if it goes on or not. Oh, okay. That is pretty much perfect. So, job done, first part complete. So it just struck me last night thinking about this, that if I want a sharp point, rather than cutting inwards towards the truck, which is what I did first time round, I'd be better off cutting away with this tool, with a left-handed tool. So I'm just setting up to do that now. I'm going to take a couple of passes, so just come out. Move along, and the same setup on the taper, cross slide set up with 15 degrees over. Right, here we go. A month ago at a car boot sale I came across a whole pile of brass scrap, and it included this stuff. It looked like a column for something, maybe a clock case or whatever. It was a huge pile of scrap. I wasn't going to separate any of it out at that point. I wondered, when am I ever going to find a use for something like this? Well, today's the day. What I was going to do was use 1/2" brass and then knurl the end for the operating bit. Don't need to. This is nice and ribbed and it's nice and comfortable on the fingers. So, starting off with machining these knobs, first thing to do is to face off, as is tradition, on all the other YouTube machinist channels. So I'm using the same speed and the same carbide tips for brass as I was using for the stainless. In fact, the Wonderful Ready Reckoner suggests I should be going a lot faster than this for brass, but I just don't have the speeds. So we're still at 640 RPM. The next thing we'll do is we'll chamfer this end. There we go with the first operation, and my wonderful grandfather clock joining in. Yep, it's 12 o'clock. So the next thing to do is to define the extent of the head. And the head ideally would have a chamfer on it as well. So what I'm going to do is I'm going to plunge in with a chamfer drill at the point I want to do. So let's zoom along here. Line that up with my existing chamfer. Taking a bit more because that will save me countersinking this end. There we go. So it looks neat from the top. Pass that through. What we're going to use is a round tool. This allows me to get straight in and then go along and leave a nice bit at either end. Okay, that's going to need clean up with a knife tool of both persuasions by the look of it. To do. Parting off, I think we will do at a slower speed, so pardon me while I switch you off for a minute and reset, and then put the speeds and I'll come back. Okay, I've slowed this down to about 200 RPM. Bit of paper to catch the object when I need it. And let's see how this goes. Okay, so now we have our points ready to go. We need to look at the rule of the rod itself. First thing we need to do is to scribe a centre line to it. Again, it's not exactly precision work, but let's just do what we need to do. Simply scribe down the whole thing. Oops, not scribe the caliper down the whole thing. That gives us a vaguely visible centre line starting point. So what do we need to do here? At one end we need to have slots that are going to allow us to position one of these wherever we want. On the other end we need a fixed point, or do we? If we're going to do this, running a continuous slot along here seems to be a bad idea because it's going to make this very squidgy. So my thought is what we'll do is we'll run 2-inch slots, 3 of them, and between each one we'll have just under ½ an inch. So at this end, this needs to be able to move from one end to the other end of the same distance as that, so that we can get we can measure the entire length of our bit there. We can't put a scale on this because it's variable, but my thinking is going to make that slot about ½ an inch, which would make the lands between these about ½ an inch. So let's go ahead and mark that up and see what it looks like. So I'm really not sure how well you can see the scribes on that. Literally, no, very little. But I can see them well enough. So what I'm going to do now is to centre punch all those marks. Then we need to set up the mill in order to drill this. So the idea will be I'll do chain drilling. Then I will find a nice small mill to clean up after myself. We'll set up the DRO to do that, but let me centre punch all these first and then start setting this up. I know that is longer than the travel, so I'm going to have to do sections at a time and then reset this. I don't think that's going to cause any major problems. But let me just centre punch this. This is actually a homemade centre punch, not by me, but again, a tool that I've acquired from somebody else's, ex-workshop. Nice thing, it's not an automatic centre punch. The problem with those, I find, is when you push it down, quite often it can move if you push it down hard enough to actually strike. With this one, you lay it and you pull that back and it hammers down on itself, which is much handier, and I find much better for getting accurate positions. So I'll centre punch this up and then I'll come back to you once I've got it on the mill. The tactics for this piece are to work at the end with the 1/2 inch slot first. Reason being that what I'm going to do is I'm going to do all the operations. Reason being, if this doesn't work for any reason, I can always change this from being a 13.5 inch device to a 12.5 inch device. So tactic is cut the smallest bit first that you can get rid of. So in terms of describing the setup I have, at the moment, as a centre drill in the chuck, the piece of metal is set for the first half of it or so, because I cannot reach the whole thing with the travel on this mill. So plan is put in 2 centres and then start drilling with the just under 3/16 drill to clear out most of the metal. And once I've done that, I've got some 3/16 I've got a 3/16 end mill and I've got a 3/16 slot drill. So we'll try the slot drill first and see how good that is at cleaning the tips out of the way. I mean, that is the finished size I'm looking for, so hopefully it's going to work this way. Otherwise I need to go through a process of drilling using a bigger drill and a smaller end mill or slot drill, and then going 2 passes. We'll try 1 pass first. If this works, then we're good. If not, I've got a 12.5 inch instead of 13.5 inch device. Point 2 again. Where's my brush? Okay, so number 1 magic tool, because there's an awful lot of winding to do on this. I use this to lift the head. Okay. 0, 0. Okay, stuck going through. Just tighten this up a bit more. Try again. Okay, so far so reasonable. I miscalculated the spacing for that a little bit, but let's put the end mill in and see what happens next. quill and drop this down and see how this goes. Okay, we have a slot. Let's just take this out and see what this looks like. It looks pretty reasonable. Let's take one of our pins. Goes in there. Let's take the other of our pins. Okay, loosen it. Put it along, tighten it. Great, one end done. So I think the next thing is to set it up the other way and do exactly the same again. Only 2 inches long each one. So here's the setup for the first 2-inch slot that goes there. What I've decided to do is to chain drill this, and I use a DRO to make it a little bit quicker. So I've set the spacing at 0.19, which is just marginally bigger than the drill size. So I'll run along here with the DRO with center drill, and then I'll come back and drill it again with the correct size drill. And then once that's done, we'll put the drill back in and that'll be fine. Alright, that's my center drilling done. Let's do a quick tool change to the drill and go back the other way. Right, that's the hole's done. We need to just run the mill along that, and we should be finished with one slot at least. Lock the quill, wind it down, put a bit more gunge on this. I think there's going to be quite a lot of cutting here. we go. Okay, that's the slot done. Let's just lift this out and have a look at it. Not too bad. The finishing there is not brilliant. I might need to just touch that up with the file. But yes, it has wobbled a bit with the drillings. It might be worth a second pass actually, just to try and clean that off. I think gravity's working extra hard in here today. Things keep landing on the floor that didn't ought to. But there we go. That looks any nicer. Still not great, but better than it was. Okay, I think I'll save you the watching of me doing that 2 more times. So I'll get on and I'll come back to you once this is all finished. So the trammel is finished, polished up slightly with Scotch-Brite. And here is the very specific job that I needed it for. What I need to do is to determine exactly what the centres are of the 2 axles. As I mentioned maybe before, using a trammel to set out everything on the locomotive, if we believe from scratch, is what you would normally do. So now I have that measurement, it allows me to get on with various other aspects of the valve gear. So essentially I can offer it up to steel rule. This is how it would have been done traditionally. So, one tool to go in the toolbox, the measuring kit. Very pleased, it's a nice thing to have in my hand. It really is a nice thing to do, to make your own tools and to have your own input to what you do and handle them endlessly, basically. Well, I'm sitting here at home trying to edit this footage for time and complexity. What I've been trying to do is to keep all these videos to around 30 minutes each. When I started out with this, I had over an hour's worth of material. So what I've done is I've basically speeded up some of the machining bits, which is something I really didn't want to do, because one thing I found when I was watching other YouTube videos, when that happens, you don't actually get the sounds and the feel of machining, which is something I wanted to listen to and see when I was, as I am learning from other people's work. So just a question for you, do you like speeded up sections, or would you like me to cut them and fade between beginnings and ends, or am I doing it right? So far I've had very few comments on this, which is a shame. Please do feel free to comment, positive or negative, and I look forward to seeing you next time.